Welcome to our video on rocket propulsion, an essential technology that propels us beyond the confines of our planet, enabling groundbreaking space exploration missions. We will dive into the different types of rocket propulsion and discuss their advantages and disadvantages. So let's launch ourselves into this exciting journey of discovery. Rocket propulsion is the driving force behind space exploration. There are two main types of rocket propulsion: chemical and electric. Chemical propulsion is the most commonly used method for rocket propulsion. It involves the combustion of propellants to release enormous amounts of energy, propelling the rocket forward. Solid rocket propulsion employs a solid mixture of fuel and oxidizer, known as propellant, to generate thrust. The propellant is packed within a combustion chamber and ignited, producing a controlled explosion that accelerates the rocket. Solid rocket motors are simple, reliable, and have high thrust, making them ideal for applications that require significant power in a short amount of time, such as launching heavy payloads. Advantages of solid rocket propulsion. High thrust. Solid rocket propulsion provides high thrust, allowing for efficient launches of heavy payloads. Reliability. Solid rockets have a simple design, resulting in high reliability and minimal chance of failure. Storage stability. Solid propellants have a long shelf life and can be stored for extended periods without degradation. Disadvantages of solid rocket propulsion. Lack of control. Once ignited, solid rockets cannot be shut down or throttled, making them unsuitable for missions requiring precise control of thrust. Non-reusable. After a single use, solid rocket motors become expendable, leading to increased costs and waste. Liquid rocket propulsion relies on the combustion of liquid propellants, typically a mix of fuel and an oxidizer. The propellants are stored separately and combined in precise amounts within a combustion chamber, resulting in controlled combustion and thrust generation. Advantages of liquid rocket propulsion. Variable thrust. Liquid rockets allow for precise control of thrust, making them suitable for missions that require adjustable speeds and directions. Throttleable. The thrust of liquid rockets can be throttled up or down, enabling delicate maneuvers during space missions. Reusability. Liquid rocket engines can be reused, reducing costs and minimizing waste. Disadvantages of liquid rocket propulsion. Complexity. Liquid rockets are more complex and require sophisticated systems for propellant storage, mixing, and ignition. Vulnerability. Liquid propellants are potentially hazardous and require careful handling and storage. Electric propulsion, also known as ion propulsion, employs the acceleration of charged particles to generate thrust. Although electric propulsion offers low thrust compared to chemical propulsion, it is highly efficient and allows spacecraft to achieve higher velocities over extended periods. Advantages of electric propulsion. High efficiency. Electric propulsion systems are highly efficient, enabling fuel savings and extended mission durations. Long lifespan. The low thrust of electric propulsion results in minimal wear on the engines, prolonging their lifespan. Disadvantages of electric propulsion. Low thrust. Electric propulsion provides low thrust, limiting its immediate power and maneuverability. Rocket propulsion serves as the backbone of space exploration, pushing the limits of human knowledge and enabling incredible scientific discoveries. So embrace the power of rocket propulsion, and let's continue to reach for the stars. Conclusion. Rocket propulsion serves as the backbone of space exploration, pushing the limits of human knowledge and enabling incredible scientific discoveries. So embrace the power of rocket propulsion, and let's continue to reach for the stars.